Welcome to 2.5 Zeros of Polynomial Functions. So our central question is, how can you solve a polynomial equation and what is a rational zero? The rational zero theorem. If f of x equals a sub n x to the power of n plus a sub n minus 1 x to the n minus 1, etc., has integer coefficients and p over q, where p over q is reduced to the lowest terms, is a rational zero of f, then p is a factor of the constant term a sub 0, and q is a factor of the leading coefficient a sub n. So what you want to do when you look at a problem like this, you want to say, what is my constant term? My constant term is negative 3. You have factors of negative 3, plus or minus 1, plus or minus 3. Your leading coefficient is 4. Your factors of 4 are plus or minus 1, plus or minus 2, plus or minus 4. So you have your factor of negative 3 over your factors negative 4. So plus or minus 1, plus or minus 3, over plus or minus 1, plus or minus 2, plus or minus 4. You want to list out all possible rational zeros now. So this means it can equal, you want to divide 1 over 1, or plus or minus 1 over plus or minus 1. So you would get plus or minus 1. 3, so plus or minus 3 over plus or minus 1 gives you plus or minus 3. Plus or minus 1 over 2. Plus or minus 3 over 2. Plus or minus 1 over 4. Plus or minus 3 over 4. All of those are your possible rational zeros. It does not mean they're all actual rational zeros, but they're all possibilities. So let's look at another example. It says find all zeros of f of x, x to the third, plus x squared, minus 5x minus 2. Now this time you want to find all zeros. So you want to begin by listing your possible rational zeros. So if you look at your constant negative 2, you'll have plus or minus 1, plus or minus 2, because your factors of 2 are 1 and 2. And then your leading coefficient is 1, so you just have plus or minus 1. So if we list out all our possible zeros, 1 divided by 1, so you have plus or minus 1, and then plus or minus 2 over plus or minus 1 is plus or minus 2. So these are your 4 possible rational zeros. We now use synthetic division to see what we can find, if we can find a rational zero along these 4 possible. So that means we're going to plug each of these in to synthetic division to see if it's a 0. So we are going to test 1, negative 1, 2, and negative 2. Let's start off with 1. We use synthetic division to solve this. So 1 times 1 is 1. 2. 2 times 1 is 2. 1 times negative 3 is negative 3. That's negative 5. So 1 is not a possibility. Let's try negative 1. So this means it's not going to be negative 1 either. So we tried the 1s, let's try the 2s. So now we have 2. Oop, that's positive 1, sorry. So that means 2 is a possibility. Or 2 is a 0. Let's try negative 2. Whoops. Sorry. Negative 2 times negative 1 is not a positive 4. It's a positive 2. Sorry. So this means it's not going to be negative 2. So we use synthetic division to test the possible rational zeros. In this case, we found 2 is our only rational 0. So we found a rational 0 at x equals 2. This means we have x minus 2, remember it has to be the opposite sign, times x squared plus 3x plus 1. So now we have one of our zeros, and now we have to solve the rest. For this, we're going to use our quadratic equation. For the solution set, I would write down the one you already have so you don't forget it. And then continue your quadratic equation. It's already set up, so let's just solve from here. We have negative 3 plus or minus the square root of 5 over 2. This won't simplify, so that means in our solution set, you just want to write negative 3 plus the square root of 5 over 2, and negative 3 minus the square root of 5 over 2. And that's your answer. So make sure you answer the questions below and watch the next videos. And next time, we are going to talk about solving polynomial equations.